Yesterday, guys, we did example A already. The instruction is find the parametric equations for any object. In this case, we have two examples, so those two objects. It moves along the ellipse of x squared divided by 16 plus y squared over 25 equals to 1. Okay, we did A yesterday. Then today, we're going to do B. Today, the object starts at a different location than yesterday. Where is it starting today? 0, 5. So again, I'm just going to draw it again to give you an idea where it starts. Same exact ellipse. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. It's your first time of this type of question, so write as much as you need. So today, we're not starting at 4, 0. We are starting at the very top. 0, 5. Yesterday, the question was, is x always cosine? And the answer is no. Okay. And would you agree, how long for this particular object to finish a full revolution? 1 second. Okay. A revolution is also called period. What is the formula for a period? 2 pi divided by b. This today equals to 1 second. Would you guys agree? That means B would be 2 pi. Nice and easy. We find B right away. Now we just have to find A and decide x is cosine or sine, and that's a day. Okay. Now this object today, is it traveling clockwise or counterclockwise? Counter. Is that right or left? Left. Okay. So it goes this way. So if it takes the entire second to finish, would you agree at the very bottom would be half a second later? Then the left side of the x-axis, how many seconds would it take for me to get to the left side of the x-axis? 0.25, a fourth. Perfect. And the right side of the x-axis will take how long? 3/4 or 0.75. I would take fractions or decimal. Okay. So that would be the time. I'm going to make a table because some of you were absent yesterday. This is time first. Sorry, time, x location, and y location. So when time is 0, this is where it starts. If time is 0, it starts at an x value or x location of 0, y location of 5. Then a quarter of a second later, where is it on the x location? -4, and y location would be 0. Then a half of a second later, where is it on x? 0. Where is it on y? That's right. Then 3/4 seconds later, where is it on x? 4, and y would be? And then as you know, a full second, I'm back to where we started. You only have two choices for x and y. X is either A, cosine, or B, time, or y will be cosine, and then you switch them. If it's not sine, then it's cosine. So your formulas would be x equal blank. Cosine or sine, this is where we will decide. Okay? And then y equals blank cosine or sine. Okay. Let's think about this for a second. We would like, when time is 0, we would like our x value to be what? Out of the two trig functions, the sine and cosine, which one will give me a 0 when the angle is 0? Only sine, exactly. So we're going to write sine for x. Do we know b already? Yeah, we found it manually, and b was 2 pi, and then we times time. If x is sine, y would be immediately cosine, and then your b is the same for both. Okay. Now we just have to find the amplitude, which is your a value. When time is 0, sine is 0 times 2 pi is going to be 0, that's going to be 0. So that's not going to help us with this. But a quarter of a second later, we would like the x value to be what? -4. So if I plug in a quarter, ready? 2 pi times a quarter. Half pi, pi over 2. Sine of pi over 2. 1. 1 times what will give us a negative 4? That means the amplitude has to be negative 4. Okay, I'm going to hold it right there. Do you guys understand how the amplitude comes about? Mm-hmm. Now, how about the amplitude for cosine? What goes in the front? 5? Let's check. Okay, to see if Evan's right. When time is 0, we would like our y value to be what? 5. All right. 0 times 2 pi. 0. Cosine of 0. 1. 1 times 5. Check. But don't just trust the first one. Let's see if this one works. Because this one has to be a negative 5. Half a second. 2 pi times half. Pi. Cosine pi. Negative 1 times 5. Is it working? Beautiful. And that's it. Do you guys see a pattern at all on those amplitudes? Look at A and B. Is there a pattern on the amplitude? Yeah, okay. So if a table helps you find the amplitude, then make a table. All right, example 4. Give the parametric equations of a curve. X equals sine of t and y equals cosine of t. T is restricted between 0 and 2 pi. Graph it and tell me the orientation. How do you want to graph it? Make a table or change it to parametric? I mean, change it to, it's already in parametric. Change it to rectangular. Pick one. Rectangular or table? Table. Wouldn't a table be a lot easier? Because isn't your time restricted between 0 and 2 pi only? So couldn't I make a table with t be 0, the main value pi over 2, pi, 3 pi over 2, and back to 2 pi? And I can have an x and a y. All right, x represents sine. Okay, so sine of 0 would be 0. Y is cosine of time. Cosine of 0 would be 1. See, not too bad. We have 1 dot already. Pi over 2, sine of pi over 2 would be 1. Cosine of pi over 2?
0.
Perfect. Sine of pi? 0. Cosine of pi?
1.
Sine of 3 pi over 2? And cosine?
0.
Last one, back to where we started, right? See, look at that. What shape is that, y'all? That is. That's it. Okay. Looks like your center is 0, 0, and your radius is 1 unit. So that means all the way around 1. That is a circle. Now, if you decide to change this to rectangular, you need to know the cosine square of any angle plus sine square of any angle equals to what? 1. In this question, cosine is what variable? Y. See this right here? So that means this is y square. Would you guys agree? Sine is what variable? X. Can you guys see that it's still coming out to be a circle with a radius of 1? Either way, it's the same. Example 5, projectile motion. Do you have those formulas under your belt? Kinda? Okay, if not, can you flip to that definition and give me the x equals and a y equals? X equals under the definition. Okay. Tim, what's your x equals under the definition?
In parentheses, v naught cosine zeta, and parentheses times t.
Beautiful. Negative?
1/2 g times t squared plus, in parentheses, v naught sine zeta.
Perfect.
And parentheses times t.
Perfect. Plus?
H.
Good. So let's talk about these really quickly. For this question, suppose that Jim hit a golf ball with an initial velocity of what? Yeah, 100 feet per second. So that is your v subscript 0. It's 100 feet per second. That's your initial velocity. Do we know theta? Theta is 30 degrees. Perfect. T represents time, okay? H represents the initial height. Do we have one for this golf question? No, because he's probably going to study on the ground. Okay, part A. Find parametric equations that describe the position of the ball as a function. So that means we're looking for x equals and y equals. We have everything we need to find x equals and y equals. So x equals v naught is what? 150. Okay, cosine of what degrees? 30 degrees, and then we'll stick the t in there because that's just a variable. We will make it pretty after. Y equals negative 1 over 2. Whoa, gee, what is that?
32 or 9.8.
But which one is this?
32.
32 because it's in feet per second. That means the gravity is going to be 32 feet per second square. So we would use 32. Okay. T squared would say is t squared. V naught is again what? 150 sine of 30 degrees, and then your t is your variable. Height in this particular case is 0, so we won't. If you need to, you can write 0 so you know why 0 later. But okay, let's simplify. Cosine of 30 is what? Rad 3 over 2. Okay, so 150 times rad 3 over 2 would be? I'll write it first. Sure. You can go straight through if you need to. I'll just write that first. How about y equals half of 32 is what? So that gets a negative 16t squared. What's sine of 30? 1/2. So 150 times 1/2. Let's make it pretty so we can box that up. Final parametric would be x equals what? 75 rad 3t. Y would be negative 16t squared plus 75 t. We'll box that up. Okay. So let me just tell you what this is. This is, remember, this is just one golf ball. Okay, this is a function, a parametric function for one golf ball. What do you think y represents? Y equals, what does that represent? The height of the ball in terms of time. What is x? Yeah, the horizontal distance, right? Wouldn't you guys agree that the ball travels and needs height and horizontal with respect to time? In Algebra 2 and lower, we have only, all these years, you've only been giving the y equals negative 16t squared. Would you guys agree with that statement? Yeah, we have never really dealt with the horizontal distance until now. So make sure we pick the right equation to solve on it, okay? How long was the golf ball in the air? Which out of those two, x or y, would we need to use to solve? Y, exactly. How long, meaning time. I need to solve for time. When the ball is in the air means when the height is? 0. So we would take the y, set it equal to 0, and solve for time. So I would be solving for factoring. By factoring, I should say. Would you agree that I can factor out a t?
Yes.
So that's left with a negative 16 t plus 75 equals to 0. Take each factor and set it equal to 0. T equals to 0 is one of it. Then, bless you, negative 16t plus 75 equals 0. That means t comes out to be positive 75 over what? 16, right? What's the unit of measurement? And which one would we be boxing? The second one, and this is second. So the ball was in the air. Someone give me that decimal just so we have an idea. 4.69, okay. So in decimals, it's about 4.69 seconds. So the ball was aloft for about 4.69 seconds. Okay. Part C, when was the ball at its maximum height, and what is it? Which out of the two equations? X and Y, which one? Y again. I'm looking for the time and its maximum. What do we call that point? When it's
The maximum.
yeah, vertex. Anybody remember how to find the vertex? Negative
B over A.
B over how many A?
Or 2A.
2A. Okay, let's find that. So that's the x-coordinate. X-coordinate is negative B divided by 2 times A. Your B value is 75, so we're going to take negative 75 divided by 2 times negative 16, which is positive 75 over 32. What's that in decimal? 2.34? Okay. Technically, would you agree that this is symmetry because it started on the ground and it's going to land on the ground at some point? Okay. Because it's symmetrical from at the beginning point and the end point. Technically, class, could I have taken this and divided by 2 to get the max? Yep. So this should be half of that only when it's symmetry. Now, when you have a height, because lots of times you said, oh, this person's going to hit at like 400 feet above whatever, right? Then that's not symmetry. That's when you cannot do that. Okay. But that's not the only question on this part. What else do we have to find?
The Y value.
The Y value, to plug it in. Let's do it. So Y equals, we have to plug it in, negative 16. Don't round into the very end, so keep your fraction. 75 over 32 squared plus 75 times 75 over 32. Now, bust out your calculator. And now you can round. But again, don't round until the very, very end, because if you round too early, you're going to be a little bit further from the truth. When you have an answer, can you compare that with your team to make sure you know how to use your calculator? And then round it to 2 decimal places. Check with your people. Make sure. Okay. What did your team all get?
For which part?
The Y.
Oh, I got like I got 263. Yeah, 263.6. Did you add it to the 75 times 75 of 32? 87.
Emma has 87.9. Someone can confirm, but I don't know. 87.9? 87.9, like that? And then what is the measurement? Feet? Okay. Okay, so the ball achieved a maximum height of about 87.9 feet at about 2.34 seconds. Okay. Right. D. Determine the distance that the ball traveled. Which value? But I have 2 of them. The seconds or the feet? Oh, okay. So are you talking about the answer for D?
Oh, never mind. That's height.
Never mind. Emma?
So this time, instead of using the Y, you use the X that way.
Mm-hmm.
And use the X equation you have and substitute it with B, which is how long it's.
Okay, so let me write the X equation down. The X equation was rad 75, right? X equals 75 rad 3t. But it's looking for the distance, which I'm looking for the X variable. That means I need to know time. Do we know the time?
Yes.
What was the time?
4.7.
Yeah, when it landed on the ground was about 4.69, but don't use that. Use 75 over 16. Okay, so X equals 75 rad 3. Use the exact. Round at the very end. 75 over 16. And now you can round, which is something seconds. Give it to me when you're ready. Oh, not second. I'm sorry. Feet. Woo, I just plugged in second. Feet. Yeah, check your calculator. Make sure it's working. So what is it? How far did it travel? 608.9 feet. So it went 600. Oh, that's a really far distance, isn't it? For a golf ball? He must be like Tiger Woods or something.
Well, you're hitting at a velocity of 150 feet per second, so.
Yeah, that's a good swing.
Yeah. Well, I think it's fast.
Okay, this is where I would like for you to test to see if you know how to graph parametric. Can you make sure the mode is in parametric, par? If you weren't here yesterday, this is important. So put in par. Remember on the left-hand side, I asked you to do the dash and the circle? Like make sure that's still there. And your window. This is where the window will be important for you for application, okay? Think about the T. It took me almost 5 seconds. So your time should be between 0 and 5. Okay, again, you guys see this? It took about 5 seconds to hit the ground. So your T max should be about 5. Your X max should be around this distance. Can you see this? So put in 700. Just a little bit high is fine. Someone said, can I put 610? Sure. Okay, a little bit more, it's not going to hurt you, especially on the calculator. So X max should be that. What do you think Y max should be about? Yeah, 190, something around there. And then hit graph. So all the mins should be 0 in application. And hit graph once you have it. Make sure you enter in your X equals in this case. X equals 75.3t and Y equals negative 16t squared plus 75t. Did you see that it's moving? What shape do you think is going to be? Yeah. Did the ball travel for you?
Yeah.
Can you trace the max for me to see if our answer works? Do you know how to trace the max? Yeah, it should work, right?
Yeah.
So if it's on the calculator, you can use your calculator for all of this. So if it's on the calculator portion, you can use your calculator for all of it. Okay? Right, E, nothing for me to write. Last question of today. Ready? Tanya, it's the last question of today. Okay. All right. Max, can you help us read Tanya?
Tanya, who is a long-distance runner, runs at an average speed of 8 miles per hour. 2 hours after Tanya leaves your house, you leave in your car and follow the same route. Your average speed is 40 miles per hour. How long will it be to catch up to Tanya?
Okay, so you have, sorry, go for it.
Because simulation of two motions is verified.
Okay, so your book will have that. So when you're doing your homework, you can use your calculator to check if you need to. So you have 2 objects. You have Tanya, and you have your car. We are going to work with parametric. So in parametric, you have an X equals and a Y equals for both car and person. Okay, so let's think about X and Y. Would you agree that X is the horizontal distance? Y is the height. If both of these things are going horizontally, would Y matter? No. So for Y, you can give me any constant you want, because Y is just a road. Okay? So it's horizontal. For the sake of graphing on your calculator, if you put this both at 1 or 0 or 2, then you won't see the difference between the two of them. So for the sake of calculator work, I usually put this as 1 and 2, just kind of have a little bit of a difference, you know what I mean? So when you can see in the calculator. So again, for Y, because it's the horizontal doesn't matter, okay, I'm just going to write under here, does not matter, just give me a constant. I normally pick 1 here and 2 here, just slightly above the x-axis, so you can see when you use the calculator for simulation, okay? The x is really what we're looking for, the horizontal distance. What is Tanya's speed? 8 miles per hour. So every hour, would you agree that she will achieve 8 miles?
Yeah.
Perfect. Okay. What's the speed of the car? 40. Of course, much quicker. But what's happening to the car? Did it leave the same time?
No.
No. 2 hours
Later.
later. So Tanya leaves, and the car leaves 2 hours later. So -2. It's asking us when they're going to catch up. So catching up means same distance or not? Yeah, so can I set the two x's equal to each other? That's all we're doing. 8t equals 40t times t minus 2. Solve for t. So do you want to distribute the 40 or divide both sides by 40? Sure, distribute both sides by 40. That's minus 80. So I'm going now to move 40 to the left, so that's negative 32t equals negative 80. Divides both sides by negative 30. So 80 over 32, which will give us 2.5 hours. Okay, now be careful. T represents what? The time when Tanya started. The question really says, what? How long will it be before you catch up? Well, how long?
30 minutes.
30 minutes is right. So make sure you write it correctly. Okay. You will catch Tanya in 30 minutes. Tanya, not Tonya, in 30 minutes. Or half an hour. Okay. How did we get 30 minutes? Remember, when did you start? T minus 2, because Tanya started at T.
Okay.
So if T comes out to be 2.5 hours, you started 2 hours later. So that means you will catch Tanya in 30 minutes. Okay? All right, that's in April. So officially.